Welcome to lecture 29, which is on various methods using GPS. So, there are basically in this lecture you will learn basically two broad methods and what are the different accuracy levels which we can achieve those methods, and how many minutes or hours of observations are required in order to achieve that. So, let us begin the lecture. We have the GPS units and we are collecting the data from these GPS units when we are out in the field. The essential condition is that it should be open to sky. There should not be any obstruction and the signal should be received directly to the GPS units. We have to avoid the situations where we have high-rise buildings, where we have high mountains, a dense forest area, or we are working under a bridge or in the tunnel. So, if possible, as far as possible, we should avoid keeping the GPS at such locations, because we will get some erroneous results. If we are receiving the signals from less than 4 satellites, then also we have to wait for some time, because these satellites are continuously moving in the orbit, and if you wait a while you will find that more number of satellites are visible, and that is the time when you can start taking the observations. So, you will find that there are certain conditions. If we fulfill those conditions, if we take care of those, we can maybe achieve some good accuracy from the observations. As we know that the positioning is calculated, x, y and z coordinates are calculated on the basis of triangulation, which we use in the normal surveying procedure, and here also we are using the triangulation process, and using that triangulation process we are getting the location on the earth surface, taking the signals from minimum 3 satellites, because they will like to intersect at a point. Now, these GPS units will display the information not only about the coordinates, what are the coordinates at that point, but we will like to see how many satellites have been tracked from that particular location, how many satellites are visible to me, what is their location, relative location with respect to each other. We can also see the signals strength. So, whether the signals which we are receiving from the satellite is strong enough to take the observations. So, once these things are taken care, the instrument can be used then taking the observations. But while taking the observations, we have to make a selection of the proper GPS receiver. It depends upon our application, of course, but we have various kinds of receiver. As you can see here, we have receivers called military receivers. They are used by defense and army people and give very high accuracy. Civilian receivers, they are available to us, we can procure it from the market, navigational also. Then there are timing receivers and geodetic receivers. So, depending upon the application, we will try to make the selection of the receiver, not only on the basis of the uses, but on the basis of the carrier signal. So, we have two broad categories. Under the civilian, we have handheld GPS unit, which is a lighter in weight. You can transport it from one place to another very easily, and mostly using for navigational purpose. They will not give you very high accuracy as compared to the another category, which is the geodetic GPS here. So, geodetic GPS will give you centimeter accuracy for the observations. So, there are applications in civil engineering, outside civil engineering, where we may require very high accuracy for our project, like we have to establish a benchmark. We have to establish the benchmark with a very greater precision. But if we are doing the alignment of a canal or a railway line, then probably because the alignment is so long, so centimeter error will not affect the length of the alignment. So, it depends upon the application we like to select the type of the receiver. Handheld receivers are cheaper as compared to the geodetic type because they are expensive. So, the selection of the GPS unit is also very important when we are talking of the data collection from these. So, we have a very large number of commercially available GPS receivers, and they vary in their price, they vary in their capabilities, different specifications are there which will determine the accuracy by which the position of the points can be achieved with those units. The more powerful a receiver is, the more expensive it will be. So, we have to take care of this particular aspect into mind. In many applications, the accuracy of a standard system is quite different also, because we may require very high accuracy in some application, we may require moderate accuracy in other applications. And receiver also vary in terms of their use. Some are very user friendly, some have the tracking capabilities which are very useful in the navigation. So, depending upon the application also, we try to make selection of the receivers. Now, different methods we should know when we have the receiver in our hand, what are the different approaches through which we can collect the data and can get very good accuracy, desired accuracy. So, we have several methods, as we can see here, point positioning method and differential method. These are two broad categories of the methods, and then we have different methods under the relative positioning methods, static method, kinematic method, and stop and go method. So, these are the different methods which we are using for different purpose. For example, point positioning methods, if we have to identify the coordinates of well defined points on the ground, then relative positioning methods are used to fix the point on the ground, and the survey is considered actually to determine the baseline, as we are doing in the normal surveying. Then static positioning method is generally the same as we are doing in the surveying, and we are identifying the coordinates of the stationary points. So, maybe the benchmark. Then kinematic methods, they are mostly useful while we are moving. So, particularly for navigational applications, they are very useful, and absolute accuracy is actually quite good. So, if we see the categories, broad categories, so we have two broad categories here. One is the point positioning method. So, we are focusing on single point at a given time, and the second category is the differential relative positioning methods. Under relative positioning methods, there are subheads like kinetic method, static method, stop and go method, rapid static, reoccupation, DGPS, differential GPS and VOS methods. So, different approaches, different methods have been proposed. Each of these methods, they differ in some aspect or the other, either the number of the observations which we are taking at a particular point, or the time duration, and also the accuracy which we are achieving. So, in a way, all these methods are related to some applications. They have some utility in some or the other applications. So, for specific applications, a specific method is used. So, if we talk about what are the application levels of these methods and what is the accuracy achieved, and what are the carriers, L1, L2 carriers, or it is working in another carrier mode. So, we have to understand that particular aspect. So, here the table gives the first column is the different methods: static, rapid static, kinematic method, stop and go method, pseudo kinematic method, real time kinematic method. And the second column mostly says that you have L1 carrier receiver and L2 type receiver. So, both receivers which are working mostly in the both frequency, but there are certain method like kinematic method and stop and go kinematic method where single frequency receiver can also be used. Dual frequency receiver are expensive as compared to the single frequency receiver. If we talk about the applications, so application will range from establishing the control surveys to continuous the topographical survey. We can prepare a topographical map from these 3-dimensional coordinate, and we can have hydrographic survey, location survey, and providing the survey for the photogrammetric control. So, there are different actually applications for which these methods are suited. As far as the accuracy level is concerned, how much is the height accuracy which we are talking about? We can get sub-centimeter from a static method, we can get same sub-centimeter from rapid static method, we can get centimeter level from kinematic and centimeter level from the stop and go method, and pseudo kinematic method centimeter and sub-decimeter from real time kinematic. So, these methods are giving us quite high accuracy, which was really difficult to achieve by some other means when we are talking of the GPS. So, let us see some of the salient points of each of these methods one by one. So, when we are working on a point positioning method, so it is pointing out to a particular well defined point. So, here we are using two basic approaches, and one is called the long term averaging of the position, and another is the differencing between the signals which we are getting. So, as it is clear from the name, in long term averaging we have a receiver which will take very long term of observation at a given point, and the duration might vary from 1 hour to 24 hours. So, when we are taking large number of observations, we are taking the mean of that observation averaging, and we are using that average. So, the process of differencing between the signals can be performed in post processing mode only when we are using the other method. But in point positioning method, we can get the accuracy of 80 to 100 meter in standard positioning services, but in PPS mode we can get better accuracy 10 to 16 meter. And if we have a dual frequency receiver and we use precise ephemeris data, then we can get the absolute position accuracy of 1 meter or better, but we have to process this data. There are software available. Once we collect the data, this is raw data, and raw data may have a certain inherent error present. So, we have to process this data through the software which is available to us when we are procuring the system. So, we process the data and then we can get the better accuracy. So, under the differential we have static positioning method. Here also long term averaging is taken at a particular point, and you can see 30 meter to 2 hours of observation at a shorter baseline of 1 to 30 kilometers. So, we have for example, we have to establish a baseline which is 1 kilometer to 30 kilometer long, then we have to take the observation at that 2 points in order to establish the baseline ranging from 30 minutes to 2 hour of observation and take the average value of that. So, here in SPS mode we can get the accuracy of 80 to 100 meter. Then there is a stop and go method, and the name itself is suggesting that we are not stopping at a point for a longer duration and we are in the move mode. So, we are moving after taking the observation for a certain while, we are moving to the another point. So, here we determine the ambiguities when we are on the fly mode, and this ambiguity is resolved, and after resolving we can get the better accuracy. In this diagram we can see that there is a stop and go method where we have the two similar identical instrument. One is called the rover and another is called the base. So, we are keeping one device on the base and the another device is called the rover device, which we are moving. So, it is fixed at the base taking the continuous observation, and rover is moving at that. So, we can get centimeter accurate positioning for a very short static observation, and our period of observation could be less than 1 minute. This method is similar to the static survey method, but what is the major difference between the two is the less time of observations. We are spending at a particular station very less time in compared to the previous method. So, we take the observation and then move to the next position, and likewise we like to complete the survey work. Then the next method is called kinematic method, and this kinematic method also, in the entire process we are resolving the ambiguity which we are receiving through the signals. It is more or less similar to stop and go method, but it can give you better accuracy. It can produce centimeter level accuracy over a distance of up to 30 kilometer. So, here also we are using 2 or multiple, more than 2. So, if we are using multiple bases and multiple over in the same survey, this method can accommodate and still will not compromise with the accuracy. You can get centimeter level accuracy using this kinematic method of taking the observations. This is a diagram which shows the kinematic method. Kinematic method is the moving, on the fly method, when you are moving from one place to another. So, this is our base station, the red triangle is the base station, and then the person is moving continuously with the rover point. For example, in the car vehicles, you can see here in the vehicle the rover point is fitted here, and there is a base station, and then both the systems, rover as well as the base station, they are communicating with the satellite and they are communicating together also. So, that is the way the kinematic approach is working, and we can get very high accuracy. You can see centimeter positioning accuracy while the antenna is continuously on the move. This real time kinematic method. So, we get the data almost in the real time through the communication channel. So, here we are using a communication channel. It could be a radio modem. So, when we are collecting the lot of data and we like to transmit this data to our central server, or there are various groups which are working in the field and they would like to collate the data at a common point, then this radio modems are used. They have a certain range, defined range. We can take the data and we can transmit the data to the from the each receiver to the base station. So, that is the kind of a approach which we use in the real time kinematic method, and we can analyze the data at the same time and can see if some more data is to be collected or some experiment has to be repeated. The RTK method can provide accuracy up to few centimeter if we have the base station about 10 to 20 kilometer whose coordinates are known to us, and we will explain you the dilution of precision diop. Above 6 is there, then it may result in the error. This RTK GPS will provide very efficient tool for conducting the survey activities in the real time. So, in the shortest possible time you collect the data, and at the same time in parallel the data could be analyzed. Although this method RTK GPS method is very widely used, but still because of the complicacy which is involved in the RTK method, and also the radio modem systems which are little expensive also, in surveying work this is not as popular. So, people are not using, surveyors are not using this method. Then we have the rapid static method. So, in the rapid static method is that there is a base station here, and you can see that all around the base station the observations are being taken. So, rapid static method is combination of the two methods. What are those? Stop and go kinematic method, pseudo kinematic and static survey method. It is a combination of that. Observations at each point, we are taking about 5 to 20 minutes of observations we are taking, and accuracy level is as good as rapid static survey or simply the static survey. This kind of a survey, rapid static survey, is very useful for short range application. We have to move in a certain smaller area, such as control densification. We have to provide the control in our area, we have to establish the control points. for our mapping work or we have to survey many points in the vicinity of the area, then this particular method is very useful. In the rapid static method, we are taking observation, as I told you, 5 to 20 minutes of observation, and this is giving us centimeter level accuracy. So, very high accuracy is achieved, and we are tracking here 6 or more satellites, and baseline is also very long. So, if we take care of these other parameters, we can achieve the centimeter level accuracy. There is one method which is called reoccupation GPS survey. Reoccupation, as the name itself is suggesting, that you are working at a particular site and then you are again occupying that particular site after a short interval of time, after a few minutes. So, you are taking the observations again. So, this particular technique is also found to be useful, reoccupation technique, and this gives fairly good accuracy. So, it is more or less similar to stop and go and kinematic method. Then we are using differential GPS, and the name is suggesting that here we have to improve the accuracy of our observations. So, two sets of units, devices we are using, and we are getting the difference between the observed values and the computed value, the coordinate range, and that difference is called the differential correction. So, we are applying differential corrections in differential GPS methods, and these corrections are transmitted to the rover station, and then immediately the corrected coordinates are obtained. So, in the differential, when we are using the differential GPS, differential positioning, we can find out from the satellite signal after applying the corrections to that particular position, and these corrections would be that we know the coordinate of the reference point, and the coordinates of the reference points are also measured. The difference between the two is the basically correction, and which is known to us, and this is fed to the receiver and correct the observations which are taken by the receiver. So, this is all called the differential positioning. So, dual frequency, if we are using dual frequency GPS receivers, they will receive the signals from the satellites in the two frequencies, L1 and L2 frequency, and it will allow us to determine very precise position. So, we have to ensure that we are using here the dual frequency GPS receiver in differential GPS. So, the 2 units are required, as I told you, and then receivers within 100 kilometer will have basically the can work very efficiently. The corrections are transmitted from the base station to the rover station, and we can get directly the corrected value. As you can see in this particular figure here, we have a base station here, this is a ground station, and then we have a mobile station. So, we are moving with this particular unit, and both are communicating with the satellite constellations. They are transmitting the signal to the base station, and as well as those GPS satellites are transmitting the signals to the rover station. So, in this figure 4 satellites are there which are transmitting the signal to both the, and then what is happening is now that whatever is the known value at the base station and whatever is the computed value at the base station, we know that, and by comparing the two together we will come to know what is the difference, and that difference is adjusted when the roving receiver is taking the observation. So, this method is called the differential correction method. So, immediately we can make the corrections. So, here also you can see that in this diagram there is a base station and there is a moving station, and they are also communicating with each other, and these satellites are actually moving. So, this moving rover station could be mounted on some device also, on a vehicle also, Then here you can see how the real time differential GPS is working. So, this differential GPS is transmitting the signals to the base station as well as the rover station, and they are also communicating. So, what is happening here in this particular case, that we know the coordinates, these are the true coordinates which are known to us. We have established the point, the system at a known coordinate system, and these are the coordinates which are the computed coordinates from the signals from the 4 satellites. So, we can get the corrections. So, correction is x minus 5 and y plus 3. So, this is the correction, and this correction is transmitted from the base to the rover station, and rover has received the coordinate as x plus 30 and y plus 60 here, but the correction has to be taken into account. So, the corrections, after the corrections, the coordinate will be x plus 30 minus 5 and y plus 60 plus 3. So, it will be effectively x plus 25 and y plus 63. So, this is the way simple in a simple way it has been shown, but this is the way the corrections are automatically applied by these techniques. So, we can actually get over a distance of 10 kilometer, as you can see here, between the base station and the rover station, we can get sub-meter accuracy, very high accuracy, provided we are taking care of the number of satellites which we are observing and their geometry. So, we can get from DGPS, we can get from our handheld systems, we can get 2 to 5 meter of accuracy. Then we can get our survey grade units 0.03 meter accuracy, and we can get very high precision 0.005 meter accuracy. So, you can see that the accuracy level is in centimeter, which we can get from these instruments. So, these are the survey grade units and very high precise units. Then the another method is the WAS, wide area augmentation system. So, WAS system was actually developed by the US, by the Federal Aviation Administration to guide their aircrafts. It has a 25 ground receiving station and also the GPS satellites. So, it has a low level geosynchronous satellites which are sending the correction messages to the GPS receiver. So, you can see here the different locations of the points to the WAS. So, we have 25 ground stations and 2 geostationary satellites in the US, and this system will broadcast the real time differential signals to the observations, and then those are corrected, and then you can get up to improved accuracy up to 7 meter with this. So, this is also one of the ways how we can improve the accuracy to augment the. So, WAS technique is there which has been successfully used, and with the help of using the clue, taking the clue from this technique, now there is a system which is called augmenting system from the various GPS devices or GPS systems which have been launched by different countries. So, different countries have launched the different satellites. So, now through the augmented system I can receive the signal in my unit from the various GPS satellites and can further improve the accuracy of my observation. So, with the help of the WAS system, the you can see here that less than 3 meter accuracy has been achieved. Otherwise, the accuracy could be of the order of 100 meter in the normal procedure. So, one can improve with these methods. So, now the question is that why we use the GPS surveying. GPS surveying has several advantages when we are collecting the data and we are deriving the accuracy, desired accuracy for our survey work. Number one is this anywhere, anytime. This is the best advantage of using the GPS, that we can carry out the accurate mapping and modeling of the physical world, whether it is a plain area or the mountainous area. I can get the signal anywhere, anytime with this wonderful device. Second is the flexibility, because this gives me lot of flexibility regardless of the visibility. So, survey stations they should not be necessarily visible to me. Intervisibility between the survey station, which was a compulsory requirement in traditional surveying work, conventional surveying work when we are collecting the data, but intervisibility may not be necessary between the several points or between the adjacent points, and still we can collect the data and use this data and can get the accurate location. So, that is the flexibility which is available with this device. Mobility is another. Then when we can collect the data, we can mount the system, not necessary we can take physically from one station to the another station, we can mount the system on the moving vehicle and take the data. So, this gives me further flexibility that on a moving platform, I can put it on the backpack also. On a moving platform you can install this and can still collect the data. The next is the speed through which I am collecting the data. This is very quick, very fast. No other method will give you directly the x, y and z coordinate in such a quick time. So, we are actually saving the time when we are collecting the data of a large area in the shortest possible way, then it is saving ultimately the cost. Accuracy level, I have shown you the different methods. If we are selecting the right kind of the GPS unit, if we are using the right kind of method for a particular application, we can get very good accuracy from these GPS devices. We have to post process the data, of course. So, we require some knowledge how to post process the data through the software in order to get the good accuracy. So, this is all about this lecture. Thank you very much.